Hi, hey, hello. It's a pleasant day and happy learning to each and everyone. So far, we have been through a lot of learnings and different topics already in this lesson. To formally start, I would like to introduce myself first. I am her Sajulga T. Sebastian, a second-year student taking up Bachelor of Secondary Education major in English. And it is a great honor and pleasure to be in your screen today and to discuss this important topic with you together with my partner, Miss Kent Sajulga. It is my great delight that we are still on track and eager to learn more in this subject, which is the Assessment of Learning 1. So at this point of time, as we learn further, we would like to welcome you to Chapter 10 of this lesson, which is the Utilization of Assessment Data. In this chapter, we will get to know the test results of students' performance that can aid in making informed decisions in order to improve curriculum and instruction of the teachers. We shall look into the different types of test scores and interpret the scores as well. And lastly, this chapter will also present test score interpretations using norm criterion-referenced interpretations. Moving on, here are the objectives or the intended learning outcome as we continue learning this topic. So, at the end of this chapter, students are expected to provide meaning to test results using norm reference and criterion reference interpretations. So now, let's proceed to the types of test scores. So, here are the types of test scores. The types of test scores. There is the raw and percentage scores, percentile ranks, standard scores, and associated with the standard scores are the z-scores, t-scores, Stanines, normal curve equivalent, and developmental scores. And later on, we will get to know this type of test scores. According to Harris in 2003, results of tests are in the form of scores, and these may be raw scores, percentile, rank, z-scores, t-scores, Stanines, or level, category, or proficiency scores. The first type of test scores is the raw and percentage scores. So, what is this raw and percentage scores? And how can we determine the raw scores? Raw scores are obtained by simply counting the number of correct responses in a test following scoring direction. So, for example, if there are 50 items in a math test and the students got 30 correct responses in a test, the raw score is 30 over 50, as you can see on the screen. The math test that the student got is 30 correct responses over 50. So again, to determine the raw score, it can be just simply obtained by counting the number of correct responses in a test. So as you can see, the raw score in the math test that the student obtained is 30 over 50. So that is the raw score. So, on the other hand, to obtain the percentage score, we just have to divide the correct responses over the number of items in a test. So, if the student got 30 correct responses out of 50, so 30 divided by 50 is 0.6, and multiply by 100 is equals to 60%. So the percentage score is 60. As a result, the student was able to answer 60% of the items. Other than that, there is also the percentile rank. So what is a percentile rank? A percentile rank gives the percent of scores that are at or below a raw or standard score. So it is used to rank students in reference sample. So noting that percentage score and percentile rank is different from each other. So in percentile rank, we can determine the rank of the student based on his or her score and compare the rank to other students who also take the test. So in percentile rank, for example, if the student got 35 and 35 is equivalent to 84th percentile, so let's say there are 200 students who also took the test. So how can we get the rank? Here is the solution. So 84 divided by 100 is equals to 0.84. As you can see in the screen, 84 divided by 100 is 0.84 times 200 times 200, which is the number of students who took the exam. So the percentile rank is equals to 168. So what does it mean? The interpretation is that if there were 200 students who took the test, a percentile rank of 84 indicates that the student is higher than 168 students. Next type of test scores is the standard scores. Standard scores. So it is difficult to use raw scores when making comparison between groups on different tests, considering that the tests have also different levels of difficulty. So an example of this is a test from a math and a Filipino subject. Do you agree that these two subjects have a different levels of difficulty? Yes, it is. So let's say if the student got 40 over 50 in Filipino subject, while in mathematics, the student got 25 over 50. We can't compare these raw scores because they are different. And as you may have noticed, a student can have different strengths and capacity on different fields. And so how can we determine and make comparison of these scores? We can determine and make comparison of these scores by using derived scores. So what is derived scores? A derived scores are a family of scores that allow us to make comparisons between test scores. Just like in the previous slide, the two different scores from different subjects, we can make a comparison into that. So first, let us define the two types of derived scores. So there are two different types of derived scores, which are the scores of relative standing, which includes percentiles, standard scores, and Stanines, while the other is the developmental scores, which are scores that have been transformed from raw scores and reflect the average performance at age and grade levels. So these are the types of standard scores. But what do we mean by standard scores? Standard scores is the name given to a group or category of scores. And each specific type of standard score within this group has the name mean and the same standard deviation. So, to further learn about the standard score, my partner Ken Sajulga will discuss the different types of categories of scores in the standard scores.
Good day everyone, I am Kent Sajulga and today I am going to continue what Ms. Sebastian had discussed earlier. Without further ado, let's begin. So there are different types of scores of relative standing. First we have z-scores, t-scores, and lastly we have Stanine. So before we proceed to the next slide, we have an example of a normal curve. As you can see on your screen, this is a normal distribution of standard deviation. Here we have our mean, which is the 0 in the middle. Yes. In the right side, we can see the positive value, and in the left side, we can see the negative value. And then in there, we can see the cumulative percentages, the percentiles, the z-scores, t-scores, and the standard 9, also known as stanines, and then lastly, percentage of stanine. So later on, we will go deep with our discussion. I will going to explain what is those types. First, we have z-score. What is z-score? Z-score gives the numbers of standard deviation of a test scores above or below the mean. So here we can see the formula of the z-score. Z is equals to our row score minus the mean, then divided by to our standard deviation. Here we have a chart. A negative z-score means it is below the average. A positive z-value means it is above the average. So we have an example of a normal curve. The mean here is 0. So if we got a z-score below the mean, it means it is negative, and likewise, if we get a positive z-score, it means it is above it means above the mean. Okay. Now let's move on to algorithm steps for z-score. This is the step on how we get the z-score. First, we have to subtract the x or z-score to the mean, to our mean. Then divide the total score to the standard deviation. So here we have an example. A score of 12 in a 20-item science test with an arithmetic average of 15 and standard deviation of 2. So the given here is our row score is 12, our mean is 15, and our standard deviation is 2. So we use the formula of z-score here. Z is equals to row score subtract to our mean, then divided by to our standard deviation, which is 2. So 12 minus 15 is equals to negative 3. Then divided into 2, that's why we get the negative 1.5. Later on, I will discuss on how this is connected to the other types. Okay. Next, we have a t-score. So t-score scale. The mean is, in t-score, the mean is set in 50 instead of 0, and the standard deviation is 10. To transform a z-score to a t-score, we multiply the z-score by 10 and add 50. Before we get the t-score, we must get first the z-score. So here we have the formula. Our z-score times 10 plus the mean, which is 50. So, earlier, we got the z-score. So, gagamitin natin yun para makuha natin yung t-score. So, ginamit natin yung formula ng t-score. So, ito yung solution. T is equals to 10 multiplied to our z-score, which is negative 1.5 plus our mean, which is 50. So, 10 times 1.5 is equals to 15 plus our mean. 15 plus 50 is equals to 35. 35 pertains the row score of 12 in the situation given in the z-score earlier. The value there is negative. So we convert it by getting the t-score. And that way it can easily understand and we can easily perceive that 35 is the row score of 12. Okay, next we have Stanine. So, Stanine, short for Standard 9, it is a method of scaling scores on a 9-point scale. So, a Stanine is a 9-point grading scale ranging from 1 to 9. So, unlike t-score and z-score, the mean of Stanine have 5 and the standard deviation is 2. So, we can see as you can see on your screen, there is a formula of this Stanine. Okay, so here I have a chart of a normal curve. So if the Stanine pertains 1 to 3, it is below average, and if it pertains 4 to 6 score, it is average, and if it pertains 7 to 9, it is above average. Okay, now let's move on to normal curve equivalent, or NCE. Actually, this NCE is similar to percentile ranks and also can relate to other scores such as percentile ranks and Stanine. So, it is a normalized standard score with a range 1 to 99. It has mean of 50 and a standard deviation of 21.6. Here we have a chart. As you can see, in the first, we have the standard deviation. In the middle, the red one, we have the normal curve equivalence. And lastly, we have percentile equivalent. What have you noticed? As you can see, there is similarities of a normal curve and percentile rank. So they are both range 1 to 99. But there is also a difference. We can easily notice that the normal curve, they are divided or added by 10. 10, 20, 30, 40, 50, 60, 70, 80, and so on. Then the percentile equivalent is only divided by 5 or added by 5 every rank of it, like 5, 10, 50, and so on. Next, we have the developmental scores. A grade equivalent describes a learner's developmental growth. It defines a person's performance in terms of the average of particular group performance. Say, for example, age equivalents and grade equivalents. Here we have the types of test scores interpretation. First, we have a norm reference interpretation. The term norm originated from a Latin word norma, which means precept or rule. This norm reference interpretation are explanation of learners' performance in comparison with other learners of the same age or grade. Norm reference evaluation determines the learner's place or rank. Say for example, the child placed 8 in a reading class. This is one of the example of a norm reference description, which is they have a rankings like that, and who got the highest scores and the lowest below the average. Another example is panlitan. A child scores uh, in a reading assessment at day 85. The child scored 85 at the reading assessment. This is another example of a norm reference interpretation. So those example represents and determine the learner's place or rank. Assessment instruments that lead itself to this kind of interpretation included standardized aptitude and achievement tests, teacher-made survey tests, interest inventories, and adjustment inventories. Netco and Brockhart stated 5 guidelines when interpreting norm reference test scores. First, we have detect any unexpected patterns of scores. This means that be on the lookout of unusual, especially extreme scores like that. Second, determine the reason for scores patterns. There is a reason in underperforming in one or more subjects of the students. Next, we have do not expect surprise for every student. So, the teacher must know how each student is performing on his or her class. Next, we have small differences in sub-test score should be viewed as a chance of fluctuation. So, differences in test scores may or may not be statistically significant to the call of what we call that instrumental intervention like that. Then lastly, we have use information from various assessment and observation to explain performance on other assessment. So, it would not be shocking to learn that students with poor writing skills in English or Filipino would obtain a low score in essays pertaining that is part of a test. Next, we have criterion-referenced interpretation. The word criterion came from a Greek word criterion, which means standards, provided meaning to the test scores by describing what the learners can and cannot do in a light of standards. Say for example, back when we are in high school, we take the test called NKI, right? So if we take that test, we have to meet some standards to know what are the possible program in senior high school that we can get. Another example is taking an entrance test in a university. We also need to get what the university standard has set. So, in the classroom reference example, we have, say for example, we have an activity which is writing an essay, and in writing an essay, there is a standard. There is a rubrics or a criteria that we must follow or we must need to get so that the teacher can interpret it na masunod nato kato di can interpret it nga nasunod yun nato kato nga standards nga giset sa maong criteria. So, criterion reference is used in diagnosing students' needs and monitoring their progress. It is likewise in certification and program evaluation. This criterion reference interpretation included percentage correct, speed of performance, quality rating, and precision of performance. When interpreting a standardized test scores, there is assumption of normality in distribution of the test scores. This is not necessary criterion reference framework. Just like what my example earlier that we need to set standards and get that standards so that this will be this we can recognize what we can do and what we cannot. In summary, assessment data provided a means to look at the student's performance to offer evidence about students' learning in curriculum, provided information about program strength and weaknesses, and guide decision making. In relation to this, there are different types of test scores that can be determine the performance of the students, such as row and percentage score, percentile rank, standard scores, Z-scores, T-scores, Stanine, normal curve, and developmental scores. So that's all for our report today. I hope you learned something. Thank you, God bless, and stay safe.